Hello, my name is Chala Kabira from CSC 110, fall of 2014, Clark Wellman's class, and this is my coin toss project. My presentation, I'll just go over my PowerPoint and then I'll, I'll just go over my code and do a couple of test runs. So before my first function, I used from random import random. The from random import random statement is written before my first function, and random is used to return heads or tails values. For example, anything less than 0.5 is heads and anything greater than 0.5 is tails. And after my random expression or random statement, I went into defining my prob function. The prob function, which is short for probability, is used to return the number of heads and tails and the number of times the coin is tossed, x being how many times the coin is tossed, 5, 10, 20, or 50. The function accepts these values and returns the number of heads and number of tails when the same coin is tossed x times, depending on the probability. And inside my my prob function, I use a set of, I set heads and tails equal to empty lists, and I use a for loop, and I also, inside the for loop, I use if and else statements, and also I appended the two lists. And after my first function, I got into my main function, and in my main function it has two user inputted values, which are coin probability n and number of times to flip the coin x. In main, the program evaluates m values, which are the values 1,000, 10,000, and 100,000. For example, for each value, that's 100,000, I believe. Yeah, 100,000. 10,000, yeah. For each value of m is multiplied with x to compute the inputted values. In this loop, prob n of x is called, and main then appends these pairs as a key in dictionary. There are a total of 3 dictionaries that I used. And inside the main function, I use a dictionary, which is a collection of key and value pairs. The probability calculation is key value over total sum of all key values, which is used for each dictionary. For each dictionary, the probability of each key in the dictionary is calculated and printed back to the user. The sum of the probabilities of each key dictionary adds to 1.0, proving that its probability is correct. And now let's go over to my code, and as you can see, as I mentioned from my PowerPoint earlier, the first thing that I did was imported random from random. Then I defined my prob function, and as you can see, this is my pseudocode, and I set heads equal to empty list and tails equal to empty list, and then I had a loop, and in my loop I have, as you can see, if statements, and I return the length of heads and tails. And now going down to my main function, I get the probability, I get n, this is my pseudocode, and I get n from the user, which is the probability, and I get the numbers of times to flip the coin, which is x, as I mentioned, and after that is my dictionary, and I set all the dictionaries equal to empty dictionary, and I set my summa cum in this case, which is sum C, and sum D, and yeah, and I set it all to 0, and then after that I use a for loop again. So as you can see here, for every m in 1,000, 10,000, and 100,000, and a is equal to current m value, so a is equal to the current m value times x, which is the number of times the coin is flipped, and yeah, I have a couple other if statements, and then I print out my function, as you can see here. And now I'm gonna run a couple test runs. Yeah, let's run a test run. Let's try a test run. Hold on. Let me clear this so you can see. So F5 saved. And let's say enter coin probability. Let's go with 0.5. And enter the number of times to flip coin. Let's go with 10. And so let me go back to my PowerPoint while this is doing its thing. When judging, so fair slash unfair coin, fair or unfair coin. When judging a coin to be fair or unfair, we could take the number of times a coin is flipped and run through a coin toss simulation. When a coin is flipped 10 times, and we know, so when a coin is flipped 10 times and we know the probability is 0.5, then we can assume that the coin is a fair coin based on the division of the coin. It is evenly divided in two, giving a percentage that is equal to each other on both sides. So as you can see here, everything seems to be correct. Yep, 10 flips 1,000 times is, and you can see the sum of the probabilities is 0.9. That was pretty much 1, equal to 1 if you round. Yeah. And now let's try an unfair coin. F5. Enter the probability. Let's go 0.6. And let's go 10 times. Go back to my PowerPoint while that loads. So when any other probability is used, we know that the simulated coin is not fair based on the division. It is not evenly divided into two, as one side is larger, or in some cases like 0.6, where you know it's obviously larger. So 0.6 heads and 0.4 tails would be considered an unfair coin. We know then that 0.5 is the only probability that simulates a fair coin. And as you can see, everything seems correct. You see the sum of the probabilities is 1.0, 0.9999, and yeah, so that's pretty much it. I've showed you my code. My code is right here, and my PowerPoint is also here. And we went through some of the test runs, as you can see. And that's pretty much it. Thank you for listening. How do I pause?